As for an example of how to construct the frequency distribution table, so we will construct the FDT. For this example consists of 50 observations by using the steps that we discussed. As for the start, we have to find first the class size. The class size is equal to the range divided by the number of classes k, and this is equal to, the range is equal to the difference between the highest value and lowest value, and the number of classes is equal to 1 plus 3.322 log of n. So since based from the given data, the highest value is 90 and the lowest value is 43. So using our calculator, we can find the value of the class size as 7.07, and rounding off this value, so it is equivalent to 7. Now we need the value of the class size in order to determine the upper limit of the class interval. So the next step is we have to construct the classes. Now, we will start with the lowest value of the observations. Now, here the lowest value is 43. And in order to obtain the upper limit, just simply add the lower limit by the class size minus 1. And since we obtained the class size as equal to 7, so all we have to do is just subtract 1, then add the 6 to every lower limit of the class interval. So, like for example, 43 plus 6, and that will be 49. And then you can proceed to the next class interval, which is now 50, and then plus 6, 56. And then followed by 57 plus 6, and that will be 63, and so on. And then the next step is we have to determine the number of observations every class interval. Now, the method involved is tallying. Now, based from the given observations here, there are 7 observations belong to range from 43 to 49. There are also 7 observations from 50 to 56. There are 10 observations from 57 to 63, and so on. And then the next step is we have to complete the table. Now the FDT contains the class mark column, the class boundary, the cumulative frequency, and the relative frequency. Now for the class mark, it refers to midpoint of the lower limit and the upper limit of every class interval. And how to determine the class mark or class midpoint, just simply add the lower limit and the upper limit divided by 2. So 43 plus 49 divided by 2, that will be 46. 50 plus 56 divided by 2, that will be 53. Now, there is another way how to determine the class mark to the other class intervals. So, upon getting the class mark of the first class interval, all you have to do is just add the class size. Now, since we obtained the class size as 7, so after getting the first class mark, just add 7. So, 46 plus 7, 53 plus 7, 60 plus 7, 67, and so on. So that is the easiest way how to determine the class marks of the other class intervals. For the class boundary, it refers to the exact limit of the class interval, where for the lower class boundary, just less 0.5 to the lower limit, and for the upper class boundary, just add 0.5 to the upper limit. So here we have 43 minus 0.5, that will be 42.5. For the 49, add 0.5, that will be 49.5. For the next class interval, 50 minus 0.5, that will be 49.5. And then upper limit will be 56.5, and so on. Now, if you will notice, there is no space between the upper limit of the previous class interval to the lower limit of the next class interval. So there is no space between these class intervals. For the cumulative frequency, it refers to the summing up or adding up of frequency. For the less than, it starts from the lowest class interval. For the greater than, it starts from the highest class interval. So we have it here, 7 for the observations, and then followed by 7. So 7 plus 7, that will be 14. and then plus 10, 24, plus 3, 27, plus 9, 36, and so on. So a total of 50. For the greater than cumulative frequency, we have to start from the highest class interval. Frequency is 8, and then add 6, 14, add 9, 23, add 3, 26, add 10, 36, and so on. For the relative frequency, it refers to the ratio of the frequency of each class interval to the total number of frequency. The total number of frequency here is 50 because that is the total number of observations. And then determine the percent relative, so just simply multiplied by 100. So there are 7 observations for the first class interval divided by 50, and that will be 14%. Again, for the next class interval, 7 divided by 50 times 100, 14%. 10 divided by 50 times 100, 20%. And so on. And then, it should be the total of this percent relative frequency is 100%.